Hey guys, Mr. Smith here, and I'm just shooting a short, probably 5-ish minute video just on a crash course on linear relations. Our course um, does not have a ton of linear relations stuff, maybe in the first unit a little bit, but I know the prerequisite work. You've got a few questions on linear relations, and maybe you need a little bit of brushing up, and I'll probably go over some things in the class with you guys. But in case you just wanted a quick fix, 5 minute, pop some headphones in. Here's some linear relations review. In grade 9, you guys were introduced to the equation of a line, the slope intercept form of the equation of a line. It was y equals mx plus b. B, that last number, was the y-intercept of your linear relation, and the coefficient in front of the x gave you your slope. So if you ever have to graph a line, a linear relation in this form, pretty straightforward. You pick off the slope, you pick off the y-intercept, and you graph it. In this one, the y-intercept staring us in the face at the end there is 5. So we would place a point at the y-intercept, 0, 5. We know our line goes through there. What about the slope? What number is in front of the x here? We have negative x as an assumed 1. It's like negative 1 times x. Our slope is negative 1. How do we graph that? Well, remember, guys, slope was defined as rise over run, right? And how can you write negative 1 as something over something else that you could draw out as rise over run? You can think of negative 1 as like negative 1 over 1. So there we go. From your y-intercept, go down 1, right 1. The rise is negative 1. The run is 1. So down 1, right 1, down 1, right 1. And just continue until you fill up your graph or you get tired. I'll just fill my whole graph up. You could connect it with a straight line, but I think for the purpose of this crash course video lesson, I'll just leave it like that. You can connect it with a straight line if you wanted to. For B, let me just slip into a different color. Slope, 2 over 3, right there. Y-intercept, negative 4. Let's graph it. Start with the y-intercept. Make a point. Use the slope from there. Slope is 2 over 3. That's a rise of 2, up 2, and a run of 3 over 3. Boom. And then just do more. 2 over 3, up 2 over 3. Ideally, this is sounding familiar from your grade 9 course. Oh, I guess I am connecting them with a line. That's what we're doing now. Are we, Mr. Smith? Okay, let's just connect that with a line then. Can't let A be not a line and B be a line. And if any of you guys know the Microsoft PowerPoint people, would love a straight line tool within PowerPoint. That'd be fantastic. Hey, let's try C. Is C a trick? 1/2 x. Where's the y-intercept? Does that mean there is no y-intercept? Sure there is. It's just that it's 1/2 x plus 0. The y-intercept is 0. The slope is 1 over 2. Let me get a different color, and we'll draw this one. What color are we feeling like? Purple? Sure. Y-intercept, 0, 0. Slope of 1 over 2, a rise of 1, a run of 2. Up 1, right 2. And just fill your graph up. Pretend you can draw. Good enough. But yeah, there's a little crash course for you guys in graphing from slope-intercept form. We're going to do one more. What about graphing from other forms? This slope-intercept form is not the only equation the form a line can come in. Here we have a line 2x minus 3y minus 12 equals 0. One way to graph this one is to put it into slope-intercept form. So 2x minus 3y minus 12 equals 0. Let's get this guy in slope-intercept form. So the first thing we want to do is we want to get the y by itself. That means getting rid of these other two terms. So minus 3y is going to stay put. 2x, see you later. You're going over, you become minus 2x. Minus 12, u2, you're going over, you change signs to positive 12. This is almost slope-intercept form, except that it's not y equals, it's minus 3y equals. We need to divide everything by minus 3. And let's clean things up a bit. What are we left with? We're left with y. We like that. Negative 2 over negative 3. Can simplify that to 2 over 3. There's my slope. 12 divided by negative 3 is negative 4. I can now graph my line using the previous method. In fact, I will do that on the next slide here. So our y-intercept was negative 4, and our slope was 2 over 3. Up 2 over 3, up 2 over 3. There we go. Now, could we have done this another way? We could have. You can find the intercepts. So if you want to find the x-intercept of a line, x-intercept always occurs along the x-axis where the y value is equal to 0. So you take your equation, which was, in our case, 2x minus 3y minus 12 equals 0, and set y to 0. Essentially what this does is it gets rid of the y term. Minus 3 times 0 is 0. And you solve the resulting equation. Move the 12 over. 2 times what number is 12? 2 times 6 is 12. Your x-intercept is 6. You can put a dot there, and look, it gives us the same graph as before. To find the y-intercept, you do the same thing. On the y-axis, all the values of x are 0. You pop in x equals 0. It's like getting rid of the x term. 2 times 0 is 0. You're left with minus 3y. Minus 12 equals 0. You solve this equation. Minus 3y equals positive 12. Minus 3 times positive, or times negative 4, excuse me, is positive 12. And you get the same y-intercept. And then, guys, if you have 1.60 and another 0.0 negative 4, that's all you need to draw a line. And if you draw a line between those 2 points, you get the exact same graph that we got from before. So if you need to graph a line that's in this standard form, you got 2 ways, guys. Rearrange it in the y equals mx plus b form, or graph the intercepts. Most people prefer the rearranging, but this is a method that works too. Guys, it's a small crash course in some linear relation stuff. Check this out, or maybe you're checking this out because it's in the first day. You're doing some prerequisite skills work. Hope that helped. We'll see you guys soon.